Mars, the red planet. It has captivated humanity for millennia. Its rusty hue, visible even to the naked eye, sparked curiosity and ignited imaginations. For centuries, Mars has been a symbol of the unknown, a celestial canvas upon which we project our hopes and fears. Early astronomers, gazing up at the night sky, noticed Mars's peculiar movements. Unlike the other stars, Mars seemed to wander, its path through the constellations erratic and unpredictable. This celestial dance fueled speculation about the nature of Mars and its possible inhabitants. Today, thanks to powerful telescopes and robotic explorers, we have a clearer understanding of Mars. We know it's a cold, desert world, its surface scarred by ancient volcanoes and vast canyons. But the allure of Mars remains as strong as ever. Why are we so drawn to this distant world? Perhaps it's the possibility, however slim, that life may have once existed on Mars, or even still exists today. Or maybe it's the challenge Mars represents, a test of our technological prowess and our spirit of exploration. Whatever the reason, our fascination with Mars is undeniable. And it's a fascination that is driving us to explore this alien world and unlock its secrets. The story of Mars exploration begins long before the space age. Ancient civilizations were well aware of the red planet, tracking its movements across the night sky and weaving tales of its significance. The ancient Egyptians called Mars Horus the Red, associating it with war and chaos. The Babylonians named it Nergal, their god of death and pestilence. These early interpretations, though rooted in mythology, reflect the human tendency to project our own beliefs and anxieties onto the cosmos. As astronomy developed, so too did our understanding of Mars. Greek astronomers such as Ptolemy incorporated Mars into their geocentric models of the universe. While these models placed Earth at the center, they nevertheless represented significant steps towards a more scientific understanding of Mars and its place in the solar system. It was not until the invention of the telescope in the 17th century that our view of Mars truly began to sharpen. Galileo Galilei, one of the pioneers of telescopic astronomy, was among the first to observe Mars through this revolutionary instrument. Though his observations were crude by today's standards, they marked the beginning of a new era in Mars exploration, one driven by observation and scientific inquiry. From these early observations, a clearer picture of Mars began to emerge. We learned that it had seasons like Earth, polar ice caps that waxed and waned, and even a day-night cycle remarkably similar to our own. These discoveries, coupled with the planet's intriguing reddish hue, fueled speculation about the possibility of life on Mars. The space age ushered in a golden age of Mars exploration. No longer limited to Earth-based observations, we could now send robotic emissaries to the Red Planet, extending our senses across millions of miles. The first successful mission to Mars was NASA's Mariner 4 spacecraft, which flew past the planet in 1965. Mariner 4's images, the first close-up views of another planet ever returned to Earth, revealed a cratered, barren world seemingly devoid of life. While Mariner 4's findings dampened hopes of finding Martian cities or canals, they ignited a new wave of scientific curiosity. Subsequent missions, such as the Viking landers in the 1970s, sought to answer fundamental questions about Mars's past and present habitability. The Viking landers, equipped with sophisticated instruments, analyzed Martian soil for signs of life. While the results were inconclusive, they provided invaluable data about the planet's geology, atmosphere, and potential for harboring life. The pace of Mars exploration accelerated in the late 20th and early 21st centuries. NASA's rovers, including Sojourner, Spirit, Opportunity, and Curiosity, transformed our understanding of Mars. These mobile laboratories roamed the Martian surface, collecting rock samples, analyzing the atmosphere, and searching for evidence of past water. Each mission added new pieces to the Martian puzzle, revealing a planet that was once warmer, wetter, and potentially habitable. These robotic explorers have paved the way for human exploration, providing us with a wealth of information to plan future missions and ensuring the safety of our astronauts. Landing humans on Mars is the next giant leap in space exploration. It represents the culmination of centuries of dreaming, planning, and technological innovation. But sending humans to Mars is an incredibly complex and challenging endeavor, fraught with risks and uncertainties. One of the primary challenges is the sheer distance between Earth and Mars. At their closest approach, the two planets are still millions of miles apart, a journey that would take roughly 6 to 9 months with current technology. This extended travel time poses significant challenges for astronaut health, as prolonged exposure to microgravity can lead to muscle and bone loss, cardiovascular problems, and other health issues. Additionally, the spacecraft must be designed to protect the crew from the harsh radiation environment of deep space. Landing humans on Mars and, crucially, returning them safely to Earth will require developing new technologies and pushing the boundaries of engineering. We'll need more powerful rockets, more efficient propulsion systems, and innovative ways to shield astronauts from radiation. Despite these challenges, the rewards of a human mission to Mars are immense. Astronauts on the surface would be able to conduct more detailed scientific research than robots, exploring the Martian landscape with a level of flexibility and adaptability no machine can match. A human mission to Mars would not only expand our scientific understanding of the Red Planet, but also inspire future generations and demonstrate the power of human ingenuity and collaboration. Section 5. Surviving space challenges for the body and mind. The journey to Mars and the challenges of living on the Red Planet present significant risks to human health. Understanding and mitigating these risks is crucial for the success of any manned mission. One of the most significant concerns is the effect of prolonged microgravity on the human body. In space, without the constant pull of Earth's gravity, astronauts experience bone and muscle loss, cardiovascular deconditioning, and changes in their immune systems. Radiation exposure is another major concern. Earth's magnetic field protects us from the constant bombardment of cosmic rays and solar flares. In deep space, astronauts would be exposed to much higher levels of radiation, increasing their risk of cancer and other health problems. The Martian environment itself poses unique challenges. The thin atmosphere offers little protection from solar radiation, and the dusty surface could pose respiratory hazards. Additionally, the psychological stress of living and working in such an extreme environment, isolated from Earth, cannot be underestimated. To overcome these challenges, scientists and engineers are developing countermeasures to protect astronauts. Specialized exercise equipment and diets can help mitigate bone and muscle loss, while radiation shielding and monitoring systems can minimize exposure to harmful rays. Addressing the psychological well-being of astronauts is equally crucial. Providing opportunities for social interaction, communication with loved ones back on Earth, and access to recreational activities will be essential for maintaining mental health during the long journey and extended stay on Mars. Section 6. Together to Mars, a global endeavor. Sending humans to Mars is a monumental undertaking, one that will require the combined resources, expertise, and ambition of not just one nation, but the entire global community. International collaboration offers numerous benefits for Mars exploration. By pooling resources, nations can share the immense costs of such missions, making them more financially feasible. Furthermore, collaboration allows us to draw upon the best and brightest minds from around the world, fostering innovation and accelerating technological advancements. The International Space Station stands as a testament to the power of international cooperation in space. For over 2 decades, astronauts from numerous countries have lived and worked together aboard the ISS, conducting groundbreaking research and demonstrating the potential of human unity in space. The lessons learned from the ISS, both technical and diplomatic, will prove invaluable as we venture further into the cosmos. Building upon this foundation of collaboration, space agencies around the world are already working together to develop the technologies and infrastructure needed for human missions to Mars. Private companies are also playing an increasingly important role in space exploration, bringing innovation, efficiency, and commercial opportunities to the table. Partnerships between government agencies and private companies will be crucial for driving down costs, developing new technologies, and making space exploration more accessible. Section 7. Mars for all ethical exploration and preservation. As we venture further into the cosmos and contemplate establishing a human presence on Mars, it is imperative that we proceed ethically and responsibly, ensuring that our exploration benefits all of humanity while preserving the scientific integrity of this alien world. One of the most pressing ethical considerations is planetary protection. Mars, despite its harsh conditions, could potentially harbor microbial life, either extant or extinct. It is our responsibility to avoid contaminating Mars with Earth-based life, which could compromise scientific investigations and potentially harm any indigenous organisms. To mitigate the risk of contamination, stringent sterilization procedures are implemented for all spacecraft and equipment sent to Mars. Future human missions will require even stricter protocols, ensuring that we explore Mars in a way that preserves its pristine environment for future generations of scientists. Another ethical consideration is the allocation of resources. The vast sums of money and human capital dedicated to space exploration often raise questions about their opportunity cost here on Earth. It is important to remember that investment in space exploration yields tangible benefits for humanity. Technologies developed for space exploration often find applications in fields such as medicine, communication, and environmental monitoring, improving our lives here on Earth. Moreover, the pursuit of knowledge and exploration is fundamental to the human spirit, inspiring innovation, fostering international collaboration, and reminding us of our place in the cosmos. As we explore Mars, we must also consider the long-term implications of human presence on the planet. It is crucial that we develop sustainable practices that minimize our impact on the Martian environment and preserve its resources for future generations. Section 8, A Martian Home Building a New World. The prospect of establishing a permanent human settlement on Mars is no longer a distant dream, but a tangible possibility within our grasp. While significant challenges remain, the vision of a Martian colony, a self-sustaining outpost of humanity on another planet, is inspiring scientists, engineers, and dreamers alike. Building a Martian colony will require overcoming numerous hurdles. We'll need to develop innovative ways to create breathable air, generate energy, cultivate food, and recycle waste in the harsh Martian environment. Three-dimensional printing technology could be employed to construct habitats using local Martian resources, reducing our reliance on Earth-supplied materials. Water, essential for human survival, exists on Mars in the form of ice at the poles and possibly in underground reservoirs. Extracting and utilizing this water will be crucial for supporting a Martian colony. Growing food on Mars will require developing innovative agricultural techniques adapted to the planet's thin atmosphere, lack of organic matter, and limited sunlight. Hydroponics and aeroponics, methods of growing plants without soil, offer promising solutions. Creating a closed-loop life support system where air, water, and waste are continuously recycled will be essential for long-term sustainability. Such a system would minimize the colony's reliance on Earth-supplied resources, allowing it to become increasingly self-sufficient. Establishing a Martian colony is not just about survival, it's about creating a new branch of human civilization, one that embraces the challenges and opportunities of living on another planet. It's about pushing the boundaries of human ingenuity, fostering innovation, and expanding our understanding of our place in the universe. Section 9. Mars awaits. Our next great adventure. The journey to Mars is not for the faint of heart. It is a journey fraught with challenges, risks, and uncertainties. But it is also a journey of immense promise, one that has the potential to redefine our understanding of ourselves and our place in the universe. As we stand on the cusp of this next great adventure, it is important to remember that the exploration of Mars is not just about science and technology. It is about the human spirit, our innate curiosity, our thirst for knowledge, and our desire to push the boundaries of what's possible. The challenges we face in exploring Mars are not insurmountable. With continued investment, international collaboration, and unwavering determination, we can overcome these obstacles and make the dream of a human presence on Mars a reality. But this endeavor is not solely the responsibility of scientists, engineers, and astronauts. It is the responsibility of all humankind to support this grand vision, to encourage future generations to pursue careers in STEM fields, and to foster a global culture that values exploration, innovation, and the pursuit of knowledge. Mars awaits. Let us embrace the challenge and embark on this next great adventure together.